Okay. So as we have discussed, anyway, it will be recorded. Therefore, once again I will tell. When we are talking about conversion of acetophenone to benzoic acid, it can be of two ways. One is by the haloform reaction. That is haloform formation, because we are talking about methyl ketones, right? So that is one reaction. So which can be given in the form of halogen and sodium hydroxide, where sodium hypohalite will be formed, which will later involve in the reaction, and under acidic condition later we are going to get the benzoic acid. That is one way. And another way is by alkaline KMnO4. And as I told, I was expecting this one from you people that day. Okay? Because already we have discussed about this reaction, methyl ketones. But anyway, so when I am talking about alkaline KMnO4, here also there will be conversion to benzoic acid, because we have discussed about alkyl benzene, so don't get confused. Although there is a ketone, even this reaction will happen where one of the carbon will be released as carbon dioxide, which we have discussed, similar to that of the ethyl benzene. Okay, there are two ways for the conversion of acetophenone into benzoic acid. Okay, so that's what we have discussed just now. Fine. So we will move to next one. Okay, bromobenzene. Next one is conversion of. You should give me the answer fast. In detail I cannot explain. In text question and all. You should tell me conversion of bromobenzene to benzoic acid. Fast. Bromobenzene to benzoic acid. Anyone? Okay. Do you really think it will go for nucleophilic substitution reaction same as that of methyl bromide and all? We are talking about bromobenzene. If that is the case, there should be an intermediate which will be like this. Yes, we should go with the Grignard reagent method. We should go with the Grignard reagent method, where one carbon will be added by having the Grignard reagent. Okay, so conversion of bromobenzene to benzoic acid will be by Grignard reagent method. Fine? All of you have understood? Any doubts? So the better method for the conversion of bromobenzene to benzoic acid is by Grignard reagent method. Anyway, in detail I am not writing, because already we have explained this reaction. You want me to write? You can follow it, right? So next one is conversion of phenylethyl. So phenylethyl. In polymers you might have discussed this one. Phenylethyl. What is phenylethyl? Okay, so that's where we have the phenylethyl. How to convert phenylethyl into benzoic acid? Alkaline. Okay, yes, of course. So that can be done by alkaline KMnO4. That can be done by alkaline KMnO4. Okay. So that's where this phenylethyl will be converted into benzoic acid by this particular conditions. Okay. In some of the cases, to increase the yield, first they will reduce this particular molecule to ethyl benzene, then they will go for this particular reaction. KMnO4, that is alkaline KMnO4. So this is how a styrene can be converted into benzoic acid. Even we can include the first step also, where styrene will be treated or it will undergo for hydrogenation, but it will be like a very specific one. Unsaturations are here also. So therefore, it can be converted into benzoic acid by alkaline KMnO4 method. Fine. So this is what we have discussed with related to in-text question. So once again I am telling, you have to practice organic chemistry, otherwise you are not going to learn. That is 100% sure. Because methyl ketone and all we had discussed, and I told it's an important reaction, but if people are not able to give the answer with respect to acetophenone, that should not happen. Okay na? So hagadre?
Explain the bromobenzene.
So that's simple, Grignard reagent method, that we have to treat this one with magnesium. Okay, we have to treat with the magnesium. So now what will happen? So we are going to have the magnesium, that is nothing but Grignard reagent, right? And later, as usual, we have discussed how this Grignard reagent will be converted into carboxylic acid. Okay, so that's where by Grignard reagent method we can do. Means carbon dioxide we have to add next step. Okay na? All of you got my point? Now we will move to the next one. That is related to physical properties. That is related to physical properties. Now, whatever we have discussed is related to preparation of carboxylic acid. Which and all method we have discussed for preparation of carboxylic acid? Can any one of you? One is from alcohol to respective carboxylic acid, then alkyl benzene to carboxylic acid, that is benzoic acid, then by Grignard reagent method where we can convert a molecule, that is alkyl group into carboxylic acids, then by using nitrile derivatives where we have discussed conversion to the carboxylic acids, then hydrolysis of esters, hydrolysis of acid chlorides, right? Then acetic anhydride or anhydrides. All these methods we have discussed about the preparation of carboxylic acids. Fine? Okay. So next one is with respect to physical properties. And once again I am telling, try to remember with respect to Grignard reagent and nitrile method. Okay. Now we will come to physical properties. So what do you mean by physical properties? That all of us we know it is related to melting point or boiling point. That we are going to discuss about the melting point or boiling point. When I am talking about carboxylic acids, when I am talking about carboxylic acids, now I will be having another carboxylic acid, because when I am talking about a carboxylic acid solution, that will be including more than one molecule naturally. So which type of interaction you expect between these two molecules? Okay, very good. One is hydrogen bond. So that's where we can have the hydrogen bond. No doubt. That's where we can have the hydrogen bond, because hydrogen is attached to an electronegative element, that is oxygen. And this oxygen is without any hydrogen. Right? So that's where a hydrogen attached to an electronegative element can interact with the neighboring oxygen. Can have interaction with the neighboring oxygen. So that's where delta positive, delta negative. That's where delta positive, delta negative. Even this oxygen can be included. Okay, because of the delta negative sign, partial negative charge, due to the presence of dipolarity. Okay, that's where we can have the hydrogen bonding. So this type of hydrogen bonding will be called as intermolecular. This type of hydrogen bond is called as intermolecular hydrogen bond, where this oxygen with this hydrogen or electronegative element is going to interact with the hydrogen, delta negative, delta positive. That can be one of the interactions. Okay. Now, along with that intermolecular interaction, any other interaction we can observe? Any other interactions? So this is intermolecular hydrogen bond, no doubt, and there are the options. So any other interactions? That can be an hydrophobic interaction. That can be an hydrophobic interaction between the alkyl group. Between the alkyl group, there can be an hydrophobic interaction, because as the length of this alkyl group increases, that means we are dealing with the hydrocarbons, right? So hydrocarbon with another hydrocarbon, they will be having hydrophobic interactions. They will be having hydrophobic interactions. So that's where, when I am talking about physical properties of the carboxylic acid, their property will be majorly affected because of the intermolecular hydrogen bond, and along with that, it will be because of, to some extent, by the hydrophobic interactions. Fine? All of you got my point? So that's where, when I am talking about lower carboxylic acids, when I am talking about the lower carboxylic acids, if I take it in a solvent which is non-polar in nature, which is non-polar. So for example, if I take water, okay, so if I take water, if I take acetic acid as the example, can any one of you tell me whether acetic acid can be soluble in water? Yes, of course it is soluble in water.
Students, wherever you are sitting, you have to be in the same place. You should not change your place ever. Here, those who have come today, please see that where you are sitting, you have to sit there till 12:30. Will you complete all the classes? Fine?
Okay. So Hagadra, my question is, as he told, yes, acetic acid is soluble in water. So therefore, whatever in the laboratory we are getting, it's not 100% acetic acid. Okay. So now when I am talking about acetic acid, if I want to prepare some other concentration also, then I can add the water to dilute the acetic acid. So what I mean to tell you is, yes, acetic acid is soluble in water. Acetic acid is soluble in water. So in that case, why it should be soluble in water? Why acetic acid will be soluble in water? Key reason. Okay, so they are talking something about dissociation. Okay, I will come to that. Any other? Any other answer? Okay, why ethanol is soluble in water? Hydrogen bond, because ethanol can make the hydrogen bond with the water. Same logic is applicable here. When I am talking about acetic acid, even it can make the hydrogen bonds with water. It can make the hydrogen bonds with the water. That's where acetic acid is soluble in water. Okay? So because of that ability to make the hydrogen bonds with the water molecule. Fine? All of you have understood? It's also intermolecular interaction, but only thing here is those molecules are different molecules. Okay, here it is acetic acid and water molecules. And due to this hydrogen bond, lower hydrocarbon containing carboxylic acids are soluble in water. Lower hydrocarbon, that is alkyl group containing carboxylic acids, they are soluble in water because their ability to make the hydrogen bond with the water molecules. Fine. So same logic is applicable if I take any other polar protic solvents. What are polar protic solvents? Same logic. Polar protic solvents, which we have discussed, especially with respect to SN1 reaction. So polar protic solvents. Any one of you? Here also I am asking. Okay? Some of them they are online. Can any one of you tell me what you mean by polar protic solvents? Oh. Yes. So polar protic solvents means which will be having especially OH linkage. Right? So they are called as polar protic solvents because they can release H+. Just now I took the water as the example. So water is a polar protic solvent. Okay? Same way we have ethanol and all. There are also examples for polar protic solvents. Okay, try to understand everything. Don't be confused. So that's why we have the polar protic solvents. So now what I need to tell you is lower acetic acids, they will be soluble in polar protic solvents due to their ability to form the hydrogen bond with the solvent molecules. Due to their ability to form the hydrogen bonds with the solvent molecules. What my point? Any doubts related to these things? Another doubts idea? Okay. So that's why we have the physical properties of carboxylic acid, which will be majorly decided by, first thing is due to intermolecular interaction where carboxylic acids will make hydrogen bond with each other. Carboxylic acid can make the hydrogen bond with each other. That is one thing. And during that time even hydrophobic interaction will be happening depending on the size of the alkyl group, depending on the size of the R. So depending on that even hydrophobic interaction will happen. That is one thing. And their solubility is majorly because of the hydrogen bond of carboxylic acids with the polar protic solvents. Okay, so that's where we have the major interaction. That is nothing but hydrogen bond. Okay, now? Any doubts with regard to this one? If you don't have any doubts, shall I move to the next one? So when I am talking about next concept that is related to chemical properties. Next one is related to chemical properties. When I am talking about chemical properties, which can be one of the factors which is going to involve in reactions of carboxylic acids. In their name itself it is there. Which can be that one which is going to have the deciding role in their chemical property, one of the important feature. Anyone? Hmm? Yes, that is their acidic character. Because all of us will know carboxylic acid. Carboxylic acid is an acidic functional group. Is an acidic functional group. Okay? So now the question here is why they are considered as acidic functional group. So due to that reason only carboxylic acid. Alcohol, we will not give it as acid. Right? So ketones, we will not have the acid as their name. It is the carboxylic acid and sulfonic acid. They are the two functional groups which will be having acids in their name. Sulfonic acid functional group, carboxylic acid functional group. So when I am telling acid, that's because of that acidic nature. So what do you mean by acidic nature? So acidic nature means that's where they have the ability to release the H plus. That's where they have the ability to release the H plus. So ಹಾಗಾದ್ರೆ when I am talking about these carboxylic acids, okay, now this will be, as we have discussed in the earlier classes also, it will be dissociated as, it will be dissociated as RCOO minus plus H plus. RCOO minus plus H plus. So what is happening here? H plus it is releasing. H plus it is releasing. That's where we have the acidic character of the carboxylic acids. We have the acidic nature of the carboxylic acids because they have the ability to release the H plus. Now, if you go back to first PU, sir, second PU only we are not remembering. Why you are forcing us to go back to first PU? In first PU, we had a topic called as chemical equilibrium. Remember that one? We had a topic called as chemical equilibrium. And I think if I am right, I think section B, right? For section B, Raghavendra sir did that one, chemical equilibrium. Okay. I don't remember for section A whether I have done. I don't think. Okay. So for anyway, whoever, it has been done for all of you, chemical equilibrium. There we had a concept called as Ka. What is Ka? Anyone from here online? What is that Ka?
Constant of dissociation for acid.
Okay, so it is a dissociation constant for a acid. A stands for acid. Dissociation constant for a acid. So ಹಾಗಾದ್ರೆ here I am talking about an acid, that is carboxylic acid. If I want to write it as Ka, how to write it? That is product of product concentration divided by reactant concentration. So in this case it is RCOO minus into H plus divided by RCOOH. RCOOH. All of you can see the board? Okay, fine. So that's why we have the carboxylic acid, which will be dissociated as carboxylate and H plus. Now I'm going back to first PU now. So that's why we have the dissociation constant Ka, dissociation constant for acid, that is Ka, so which is equal to carboxylate concentration H plus concentration divided by reactant concentration, that is carboxylic acid concentration. Whether I am clear? Huh? 920 lah. Oh. Okay. So that's where we have the Ka, which will get dissociated as like this. Dissociation constant. I have two acids. This let it be RCOOH, and I have R prime COOH. Okay? So try to understand this. Already everything we have discussed in first chemical. So this is where we have the carboxylic acid, and this is the dissociation constant. Same way, if I want to write it for this one, I will take it as Ka1. So now it will be R prime COO minus, then H plus concentration, then R prime COOH. Any doubts here? Whatever I have written, any doubts for any one of you? All of you can see the board, right? Okay. That's where we have the R prime COH Ka value, R COH Ka value. Now I will tell that, or we will assume that R prime COOH is a strong acid. R prime COOH, R prime COOH is a stronger acid compared to RCOOH. Whether I am clear? So whatever I have written here, where R prime COOH is stronger acid compared to RCOOH. Now I want you people to tell me in terms of their Ka value. Whose Ka value will be larger? Whether Ka1 will be larger or Ka will be larger? Okay, according to Mayan, Ka1 will be larger. All of you will agree with that? Or any other answer? No supporters for you. We will go with him? Oh no. He is right. Ka1 will be of larger value because since I am telling that R prime COOH is a strong acid, that means it will give many amount of H plus. What I need to tell you is the dissociation of this molecule. This one I am talking about, this one where Ka1 is there. So this will be faster, or it will be highly dissociated compared to this one. Because this is less acidic, I told now. So due to that, what will happen? Due to that, this dissociation will be slightly less. So naturally, numerator value will be larger for this one. Numerator value will be smaller for this one. Okay? Other than I got my point. Okay, what is happening here? We had a carboxylic acid which will be dissociated like this, and this is the Ka value. And we have another carboxylic acid where alkyl group is different. Okay? And it will be dissociated like this. Now I am telling that this is a strong acid compared to this one. In that case, naturally Ka1 value should be greater compared to Ka value. So due to that, I have written Ka1 value is greater than Ka. It's clear? You should be loud enough. Because your eyes are not telling anything. And your face is half its mask. You are wearing the mask. That's what I told that day also. It's very difficult for teachers. If your eyes are not telling anything, it's like neutral. That's all, like this. Whether you have understood? Not understood? What I will do? Because this much only I can see. Huh? Now I am laughing. Can you see my eyes? Whether that I am laughing? You can see, right? That means our eyes will tell the story, reality. But if you don't speak with your eyes also, then it will be difficult. Okay. Since people have told you have understood, next point I will tell. That is pKa value. Remember this one? Next one is pKa value. What is pKa?
Minus log of Ka.
That is nothing but minus log of K, no doubt. Just like pH. pH is equal to negative log of H plus concentration, right? Same way pKa means negative log of dissociation constant. Since we are dealing with the acid, therefore we are mentioning it as Ka. That's it. Okay? Now, if I am talking about pKa1 and pKa2, if people give me the answer related to Ka1 and Ka2, same thing if I apply with pKa value, which will be greater? Sorry, full confusion, sir. Huh? Okay. Ka, I don't want Ka, I want in terms of pK. If people told me that Ka1 will be greater than Ka. Same way, if that is the case, what will be the relation between pK1, okay, pKa, because pK2 I am not written, na? pKa will be greater. Fine. All of you will agree with them? Confusion is like fine, that is absolutely correct. Ka1 is greater than Ka. Okay, Ka1 is greater than Ka. Now, what is the relation between Pk and Ka? That is Pk is equal to minus log of Ka, or Pk1 is equal to minus log of Ka1. Right? So that means as this value increases, this value should decrease. Because according to logarithm law, what it tells? It can be written as pK1 can be written as log of 1 by Ka1. Right? So they are inversely related to each other. So this value increases, this value is going to decrease. Based on that, we can tell that since Ka1 is greater than Ka, it should be Pk1 should be lesser than Pka. Why I am stressing this one? Because when I am talking about acidic character of a molecule, we have strong acids, and weak acids. We have strong acids and weak acids. Now what do you mean by strong acids? Which will be having low pKa value. What do you mean by weak acids? Which will be having higher pKa value. Whether I am clear? So strong acids are those which will be having pK value less, and weak acids are those which will be having higher pKa value. So that's where we have the strong acid and weak acids. Now when I am talking about this concept, if I take carboxylic acid organic compound, if I take, all of you have understood this one, shall I remove this? So if I take this one in my mind, when I am talking about carboxylic acid containing organic compound, they don't have same pK value. Naturally, although there is a common ingredient, that is carboxylic acid, no doubt, but still they will not have the same pK value. What is the reason? Because of its partner. Because of the difference in its partner. Say for example, which is that partner? Raghavendra, sir. R. Right? That is alkyl. Okay? The partner is alkyl, who is going to decide the acidic character of the carboxylic acid. A simple example I will take. I have, what is this? Madam, first of all, mask hakidira. Mask ready. The mask acetic acid or ethanoic acid, no doubt. It is acetic acid. Sir, mattena kan ಬರ್ದಿದ್ದೀರಾ? So ಹಿಂಗೆ ಬರೆಯೋದು ಬಿಟ್ಕೊಂಡು ನಮಗೂ confusion. Alva? And all same. Why I have written like this, you will understand. Same way, I have trifluoroacetic acid. Trifluoroacetic acid, TFA. So this is trifluoroacetic acid. This is acetic acid. Got my point? So what is the difference between these two? Here it is CH3COH. In another case it is CF3COOH. Now if I take acetic acid, don't do this one. Simply I am telling. If I take acetic acid, if I put it in my hand, not here, you put it here, then the more damage will be there, if it is there. If you put it here, acetic acid, for 1 minute, no need to worry. Nothing will happen. Whatever your laboratory acetic acid is there. Okay? Now wash it off. Now put TFA. Don't do. Once again I am telling. Okay? So now you can see the damage which can be caused by TFA, which is not caused by acetic acid. That is because trifluoroacetic acid is a strong acid. Trifluoroacetic acid is a very strong acid, having pK value somewhere less than 1. Not negative, but somewhere less than 1. But when I am talking about acetic acid, it is a weak acid, having pK value. Exact this one I don't know. It will be bit near to 6. Near to 6 to 7. Somewhere there. Exact this one I have forgotten. So that's where we have the acetic acid and the TFA. So what is the pK value for TFA? pK value here is less than 1. Less than 1. Maybe if I am right. 0.6 or 0.6. Somewhere in that range pK value will be there. But if I take here, the pK value will be somewhere around 6. We will take it as 6. Can you compare between these two? One is 6 and another one is less than 1. Almost potent to that of the mineral acids. Not same, but almost. Right? So that shows the effect of the partner. Both are having carboxylic acid, but still this is having a strong acidic character, this is having a weaker acidic character. So who is the deciding one here? Partners. Because this is constant, it is same for both. Okay. Once again, based on the first view, basic concepts of organic chemistry. You should give the reason why trifluoroacetic acid is having strong acidic character compared to acetic acid. Yes, okay. What is that called as? That is called as inductive. What he is telling here is fluorine is acting as a electron withdrawing group. Of course, because fluorine is an electronegative element. It will be pulling the electron towards itself. So that's where inductive effect, because whatever this pulling effect is there, it will move to next bond present between carbon-carbon. Okay, now what is happening here? We have fluorine and okay na? So already carbonyl group is torturing this oxygen. It is torturing this oxygen because this electron will be pulled towards the oxygen. So therefore this carbon will be asking oxygen, please help me out. So because of that, this bond has become weak already. But above that, there are 3 villains here. Who are those villains? 3 fluorines. Even they are giving or they are enhancing the electron pulling. They are enhancing the electron pulling. And this carbon now from both the sides is having the torture. From this oxygen also, from this carbon also. So due to that, this bond will become much more weaker. So therefore, OH bond will be easily cleaved and it will be released as H plus. And this is nothing but inductive effect. This is nothing but inductive effect. Okay, all of you have understood? Now, one of the deciding factor for acidic character of carboxyl group is its partner, that is alkyl group. Under which condition and under which form those alkyl groups are present. So based on that, their acidic character is going to be decided. Their pK value is going to be decided. This much you have understood? Any doubts? Same way. ಆಯ್ತು ನಮ್ಮ ಟೈಮ್ ಆಗ್ತಾ ಇದೆ. Same way, we have benzoic acid. Same way, we have the benzoic acid. Okay? So if I want to compare benzoic acid with the, once again, CF3COOH, trifluoroacetic acid, which will be a strong acid. For online students, I am really sorry. If I want to see the message, I should come there and I should see. Okay? Benzoic acid and trifluoroacetic acid, which is strong acid. Naturally, trifluoroacetic acid. What is the reason? What is the reason? Naturally, it is trifluoroacetic acid, no doubt. What is the reason? Positive resonance. Okay. It will be negative resonance. Carboxylic acid attached to a ring structure, it will show the Brinda. She is telling negative inductive effect. Okay, fine. Okay, fine. It will be having resonance effect, right? So where carboxyl group is going to drag the electron towards the ring. So due to that, what will happen? Due to the movement of electron in this direction, this carbon will be a bit relaxed. It will not give much torture to this oxygen. It will be a bit relaxed because there is a resonance effect due to this particular carboxyl group. Okay, na? So due to that, this bond will become weak. Means this bond will not become very weak. And so until unless this carbon is getting a source of electron, until that time it's going to torture this oxygen. Otherwise it will keep quiet if someone else is there. Here we have the ring structure, pi electrons, alternate pi electrons are there, right? So they are giving relief to this particular carbon. But that is not the case here. Here no one is there. Here it is the negative inductive effect which will forcing this particular TFA to become a strong acid. Okay? Fine? So try to understand the reasons. So by this, anyway, by these two things, I will stop here, and tomorrow once again we are going to continue with the same concept. Any doubts? Even online students, any doubts? So thank you then. Thank you everyone. But have a look on this PK concept. Tomorrow we are going to study in detail. It may help you out in your competitive exams. Okay na? So that's where you should be understanding the concept properly. Fine? Thank you. Thank you everyone.